All right. So let's talk about rotations. They can be the most difficult because the orientation of a rotation tends to change. It's not like a slide where it's facing the same direction, or reflection, which is exactly a mirror image of the opposite. The actual vertexes, the points, will change which way they are going. Okay? So it says a rotation turns a figure about a fixed point. Okay? The center, or the center of rotation, the axis of rotation in this particular case, for this class, it will be the origin. And remember, the origin has a coordinates of what? Tell me the coordinates of the origin.
X.
0, 0. Good. 0, 0. All right. So when we rotate, you need to know how many different quadrants each number of degrees are. Okay? So if I say rotate it 90 degrees, okay? How many quadrants are we going to move? In other words, are we going to go from 1 to 3, or 1 to 4, or 1 to 2?
Go 1 to 2.
So it's only going to move how much?
90 degrees.
One quadrant, right?
Yeah.
It's only going to move one quadrant. Does that make sense?
Yes.
So 90 degrees, we're going to move one quadrant. Now, clockwise or counterclockwise, if you're not sure, literally look at the clock and see which way that red hand is going. Clockwise, it goes to the right. Counterclockwise goes to the left. We know that? Let's write it. Clockwise goes which way?
Right.
Right. Counter clockwise goes which way? Left. Okay? So clockwise goes to the right because that's how they're going to say it. Now, so 90 degrees you'll need to know we move one quadrant based on the clockwise or counterclockwise, it'll be right or left. All right, how about 180 degrees?
It's going to be two squares.
Two quadrants?
Yeah.
Good. So we're going to move two quadrants. Move two quadrants. Now, does it matter which way we go?
No. Yes.
So with 180 degrees.
Yeah.
Does it matter if we go clockwise or counterclockwise?
No. I say
Who says no? Raise your hand if you say no.
I say
Does not matter which direction you go.
Well, it does, but in this
Why, Rebel?
it would make a difference.
They give the same coordinates. But another.
Anybody else, Stephanie? Exactly.
Yeah, I was right.
You will end up in the same location, right? It doesn't matter if you go this way 2 quadrants or this way 2 quadrants.
Oh, you mean 2 quadrants?
Yeah.
I thought you said.
No, I said 180. That's 2 quadrants. So it doesn't matter if you go counterclockwise or clockwise, you end up in the same spot, yes? Okay. So they will tell you, like this one says, going counterclockwise about the origin, okay? But we're going to end up, if we start out in 1, where are we going to end up?
2.
180 degrees,
Oh, 3.
right? So we're going to end up in quadrant 3 if we start out in 1. Depends on where we start, okay? Now, here is the tricky part, okay? Do you remember what the coordinate signs are when you were in quadrant, if you have a point in quadrant 1? Both the x coordinate and the y coordinate will be what? positive, positive, right?
Yeah.
Both of those coordinates will be positive. Okay? How about if we end up in quadrant 2?
Negative, positive.
Negative and what? Positive. You need to write these down because these you have to know these. Because that way you won't have to remember the whole rule.
Negative, negative, and not.
Okay? Next, if we end up in quadrant 3, negative, negative, right? Okay?
Positive, negative.
And then if we end up here, what are we going to end up?
Positive,
Negative.
Positive,
negative.
negative. Okay?
Ooh, this is nice confused.
All right. I want you to, now here's what we're going to do. Let's, because I'm changing these notes up a little bit because we're not going to use trace paper or patty paper anymore to rotate. Okay? Patty paper is literally what they put in between the hamburgers. Wax paper.
Oh, yeah, like my, with the frozen.
Yeah. So, but we use that as trace. Use that as trace paper,
Ew.
as you can see through. Okay. Before they put it in between.
Oh.
Right. So I want you to label. I want you to label your paper, Brandon. I want you to label it. Let's label this pre-image. Let's label it A, B, and C. Okay? A, B, and C. Label yours A, B, and C. A, B, and C. A, B.
Oh,
What's C?
cat.
One,
What
one.
does it say?
One, one.
Say? Anybody say?
Uno, dos, tres, cuatro,
We're
cinco.
using
All right. Now, I want you to, now here's what we want to do. So let's relabel them. Okay? So which one would be, now it's easy to keep track of this one if you write the 90-degree box. Okay, right there. So let's call this one C prime, okay, A prime, and B prime. Okay, watch, come here, this is fun. Now, let's write the coordinates for A, they say.
Why are you speaking like that?
So A would be what?
Apple.
2 what?
4.
2 and 4, right? How about what is B?
4 and 4.
1, 2, 3, 4.
4 and 4. I finished it.
4 and 4.
Yeah.
And what is C, Roberto?
2 and 1.
2 and 1. Now, let's write,
Oh, you just put them in negatives next.
hold on, let's write A prime, fill in A prime, B prime,
B prime.
and C prime.
Wait, by our own?
Fill those in.
By our own?
Yeah, on your own. Fill those in. ABC prime.
For what? 180?
Just for the one we're working on, the example.
What's the rule?
For 180.
So what is A prime?
Negative.
Is that what you got?
Yeah.
Yeah, it's just a total opposite. Because it's 180.
Why are you staring at
How about B prime?
Negative 4, negative 4.
B from, I got negative 4, negative 4.
Negative 4, negative 4.
Oh.
What is C prime? Negative 2, negative 1. Now, here's the thing. The rule for 180, what do you notice about the difference between the pre-image and the rotated image, Roberto?
They're just negatives now.
They're just the opposites of the same coordinates, right? Opposites of the coordinates are the same, 2, 4, 2, 4, except it's the opposite, -2 and -4.
Yeah.
So the same coordinates, you just take the opposite. Now in this case, where it lands is, don't remember that it's negative though, because here's the problem. It's not always going to start in quadrant 1. If it starts in this quadrant, it could start there, and I say 180 to there, then it would start out as negatives and go to what?
Positive.
Positives. So remember opposite. Don't remember that it's always going to be negative when you go 180s, because it doesn't matter where you start. What you have to remember is that it's the opposite. Okay?
Yeah, okay.
Now so when we go 180,
That's half the circle.
we have the same coordinates, we're just facing a different direction, right? So if I stand here facing you and I turn 180 degrees, right? Now where am I facing? That way, right? See how they're facing this point, this vertex
So if you
is
do
facing this
90,
way?
This way.
Exactly.
If you do 360.
You're back where you started, right? Now, if you go 270, I don't really like to go 270. What is the same as 270? 90 the other way, right? So in other words,
Frankie Monkey.
watch, come here, this is fun. If I say go 270 counterclockwise, where would you end up?
That way.
If I started in 1,
Quadrant.
I would end up in the 4th quadrant. If I said go 90 clockwise, where would I end up?
Fourth one.
See, 180 is the same. It doesn't matter which way we turn, right? 180 is the same. It doesn't matter which way we turn. 90 does. 270 is just turning the 90 the other way. So in other words, 90 counterclockwise is the same. 270 counterclockwise is the same as 90 clockwise. All right? And that means you only have to turn once. Because here's what's really going to happen when we go to the other example. Okay? Is actually, well, here's what happens to the coordinates when you move 90 degrees. They switch. They switch places. Okay? When you go 90 degrees, the X and Y switch places. And then when you go 180, they do what? Switch back to where they started. Except they're the opposite. Then when you go 270, they switch again. So every 90-degree turn, the coordinates switch. Okay? All right, everybody stand up. Stand up next to your desk. I want you to look down at your toes. Unless Mo, you probably extend into 2 squares, but let's try to get into 1 square. Put your toes facing me.
I'll fit 1 square even.
Well, that's because you're buying the wrong size shoes.
Yeah,
All right, see the top 2 corners of the square? Put your toes in the top
I'll fit.
2 corners.
I'll fit.
Like, so, I want your feet, the middle of your feet, go right through the 2 outside lines and your toes in the corners. So scoot up though. Gotta scoot up. No, you see how my toes are on these 2 corners? Right there.
Yeah,
And right there. There you go. Good. All right. Everybody got that? Okay. So here's what I want you to do. I want you to turn 90 degrees counter. No, I want you guys facing the front. Toes should be facing the board. There you go. Toes facing the board. All right, here's what I want you to do. I want you to turn 90 degrees clockwise, which would be which way? To which way? You're right. You guys will be going that way. I'll be going the opposite because I'm facing you, right? But watch, I want you to put your toes. Your toes need to be in the, check your toes. See, my toes are on the two right angles there. Now I want you to move them just 90 degrees, okay? Facing that, you guys should be facing that way.
Hi.
Now look down at your toes,
Fine.
okay?
can't see your toes, you can see your shoes.
Well, yeah, look down to the tips of your shoes and where they are located in relation to the square. All right, go back to the front. Go back to the beginning. All right? So when you turn, watch what's happened, where they go. All right? They're switching places. When you go 90 degrees, you rotate. Now go 180.
Oh, imagine.
See, your right toe is where your left one was, and your left one was, but they'll still be in the same place. So what happens is when you go 90, they switch coordinates, and then when you go 180, they switch back, so they never really change, right? Except the sign will be the same. Okay? So when we go 270, keep turning, go 270. That means you keep going right, 270. You guys should be facing that way. I'm facing this way. Okay? They were the same as what? They were the same as 90, right? Except we switch back, switch. Now if we go 360, obviously we're back where we started, okay? So what's going to happen up here is we are going to switch. What happens to coordinates? X and Y switch. Then they switch back. Then they switch again. But they're really not switching back. They just keep switching. All right, so let's look at example 6. I want you to write down, we're going to skip 5 because that's another 180, okay? So let's go to example 6. This is the most difficult one. You need to understand, we're going to go to 6, and I want S-T-U-B-W. So let's go, I want you to write T. Go ahead and take up your whole paper. Write the T, U, B, W. So write the coordinates for that. All right, write the coordinates. T,
FCPS.
We have to do the prime ones too. Are we doing example 5 or 6?
example 6 we're on.
Have we just school yet? But back is even I'm laughing. Back is even
I wasn't laughing.
All right, so that's what I got. Is that what you guys got?
Oh, yeah.
No, I just want you to write the pre-image.
Oh, yeah. I was working on the other one.
Let's check our answers up here.
That's
Okay.
so long.
Let's check our answers up here. So, let's go. It says, which way are we rotating?
90 degrees clockwise.
All right, which quadrant did we start in? 1. Which one are we going to end up in?
4.
Right? 90 degrees counterclockwise goes left. Counterclockwise. All right? So, here's what happens. Here's what you're going to do. Okay? You got to switch you got to switch the x and y coordinates. So T prime would now be 6 and 2. Okay? U prime would now be 2 and 1, and we'll put the signs with them at the end. This is the easiest way to do it. V prime should be 2, 4, and W prime should be 6, 5. Now, since we are ending up in quadrant 2, the signs, remember back up here? Remember, if we end up in quadrant 2, our signs are going to be what?
Negative, positive.
Negative, positive. So we go here, and we go negative, positive, negative, positive. X will be negative, Y will be positive. So now let's draw that, okay? Did you see what I did here? Come here, watch, this is fun. When we go 90, we switch them, and look where they end up. Wherever it ends up, because this will be negative, positive, okay? So the x's will be negative. So let's draw this. T prime will be negative 6, 1, 2, 3, 4, 5, 6, and 2. 1, 2, 3, 4, 5, 6, 1, 2. That is T prime. Let's go to U prime. Negative 2, 1. That's U prime. Let's go to V prime, which is negative 2, 4. That's U prime, right?
It's sideways.
I'm sorry, that's V prime. V prime, right? V prime. And then we got negative 6. What?
And 5.
1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay? So look. That's why it's difficult, because when you rotate it, you think it's going to look, you're used to seeing shapes like, just like a skinny rectangle here, and then when it falls, when you start adding slants and stuff to the shape, it's very difficult to turn it without using the rules. It's very difficult to turn it, because that doesn't look like it's been turned 90 degrees, does it?
No.
You know why? Because it's a parallelogram and not straight lines. See, if you turn something like this, if we turn that, it's probably going to look like this, right? 90 degrees. But when you got this parallelogram, which is slanted, it doesn't, the optical illusion is it doesn't look like it's been rotated exactly 90 degrees. So it looks almost like 45 or 60 degrees. That's why you have to use these points, because you're going to get these irregular shapes that you have to turn. And it's very hard to visualize that. So we go 90, we switch them, and then wherever it ends up, you take the opposite of that. I mean, wherever it ends up, you find out what those two x and y coordinates should be, positive or negative, and then you go from there. Okay, dilations, easy. Dilations is a scale factor, and a scale factor means multiply. That is it. That is it. So look, it says multiply each coordinate of the vertices by the scale factor. That's all you do, is find the coordinates and multiply it by the scale factor. If it's less than 1, did it get bigger or smaller?
Smaller.
If it's less than 1, it got smaller. If it's bigger than 1, it got bigger. That's all you do, is multiply by the scale factor. So look, here, step 1. This example, the scale factor was 2. So we multiplied each coordinate by 2. That's all you do. Okay? Multiply each coordinate by the scale factor. And then you draw it. That's all you do. Okay? So, in this one, we dilate example 8. Right, so I want you to write all the original coordinates.
All of them,
Here they are.
every single one.
There's only 6 of them. Write those coordinates here. I'll give you the letter. Come here, come here. A,
Let me go to
B,
this one.
I can't even
C,
you're right.
D, E, F. All right, riddle me those coordinates, please. Brian, let's go. Riddle me those coordinates.
So what do you want us to do?
Find those coordinates, please.
What they equal?
Yeah, what they are, yep.
I found a coordinate.
Brian, let's go.
Oh,
Brandon, let's go.
coordinate. We did. Just
Difficult. Wall is hard. It's difficult finding the coordinates. That's all you have to do so far is find the coordinates.
That's what
Are you saving on homework?
Gene,
are you
letting me down.
Did you not put front and back in? Mr. McGee, did you not put front and back? Mr. McGee, put front and back. All the teachers.
It's printed, but I hit staples and I moved staples. All right. So what did we get for A?
-5, 4.
You got what?
-5, 4.
-5, 4. All you're going to do is multiply that by 1/2.
Or divide by 2.
Or divide by 2. So A prime would be what? -2.5, 2. A prime, that's the new one. That's all you do. It's just multiply by 1/2 for each
As simple
coordinate.
as that, huh?
Okay, simple as that. Simple as that.
What do I
Huh?
What's the X? This is so long for our homework.
Try that red stapler there. I do. Now this is everything that we've learned.
Oh no.
That's all homework.
I'm gonna walk in the class and take it.
I'll give it to you, folks.
I have
70 acres. I think I might have gotten lucky there. Bye. Have a good weekend. I got him.
Giving us a lot of homework.
It's only 6 pages.
I was planning
That's
on
it?
My
That's so...
Yeah, but it's only like 10 problems because the problems take up a whole page.
Okay. I'm going to my doctor. Actually, I'm going to park.
Let's go through that. Sorry.
Oh, no, I'm not. Oh, yes. No, wait a minute. Oh, no.
Thank you.
Have a great weekend.
Thanks, you too. So. Open it up. Thanks, you too.
Why did you erase Jalapeno Joe and left his leg there?
I want to see.
This is Jalapeno Joe.
Who?